Our project is potato leaf disease classification using deep learning. So potato leaf disease classification using deep learning is our project, and it is presented by K. Sai Balaji, myself, and V. Janardhan and Lakshman Das, and it is supervised by Mrs. Usha V, Assistant Professor. The agenda of our project is all this abstract, objective, introduction, literature review, design and methodologies, standards and policies used in the testing and input-output, and the conclusion and future enhancements, and the poster presentation. Abstract. Abstract of project is that the farmers who grow potatoes, they are facing a lot of economic losses every year because of the various diseases that can happen to a potato plant. Most potatoes are affected with diseases such as early blight and late blight. Late blight is caused by a pathogen named phytophthora infestans, and early blight by fungal pathogen called Alternaria solani. And it is resulting in the abundant reduction in potato production. In India, mostly the farmers use traditional methods in identifying such diseases by inspecting visually and for removing abnormal plants during production. Highly experienced labor is required. But this method involves more effort of the labor, time taking and costly, and the result thus obtained might not be accurate. So we are using deep learning CNN architecture and the VZ19 model for data cleaning, pre-processing. We use TensorFlow dataset, data augmentation, and build the model using CNN, which is a standard way of for image classification. We used a dataset of 1000 images of early blight and 1000 images of late blight with health image dataset of 152 images, which are trained using VZ19 and gave a result of 98.3% confidence. The aim of our project is to develop a model which detects the leaves affected by diseases such as early blight and late blight by using VZ19 architecture. Traditionally, recognition of plant infection has depended on human notion by visual probe but doesn't give results accurately. Thus, it leads to reduction in the yield. So, to tackle this, we had come with this project. The main aim of our project is to identify the disease of a leaf disc is affected with. The scope of the project. The scope of the project is identifying the several problems that occur to a potato leaves by applying the VG19 model so that they can identify disease of potato plant affected with for increasing the crop production. Introduction. The potatoes are the widely referred as king of vegetables. It has become part of our meal. But there is due to some of the disease because of the diseases it is getting affected with, there is decrease in production. And being the farmers, they are unable to know what kind of disease is affected until it becomes to the final stage. So there is decrease in the production of the potato. And there is a decrease in there is some in it is having some impact on the national economy also. So to avoid this problem, to tackle this problem, we came with this solution to detect the potato plant disease at an early stage by using the VGG19 model. And there are also some other models which are used, which can be used such as LeanNet, AlexNet, VGGNet, or ResNet, etc. But among all of these, the deep learning has proved to be an effective approach for traditional computer vision problems such as image classification, object detection, and segmentation. Since it is capable of extracting features hierarchically, in addition, the applications with deep learning in agriculture, they showed recent unprecedented advancements, especially in precision farming. It has been deployed for weed detection, agriculture pest detection, and selective fruit harvesting as well as leaf counting. Furthermore, deep convolutional neural networks, one of the most used deep learning algorithms, combined with computer vision techniques, have been exploited for crop disease classification and detection. And the literature review from the paper of application of neural networks to image recognition of wheat rust diseases, which have been by Genev and Michael. From this paper, we focused on the procedure have been recently used in the farming. These procedures are nearly productively used in computer vision farming. From this, we found that cannot be directly applied to short focal length of camera. And the paper improved segmentation approach for plant disease detection by Rahman and Arifa. From this paper, we found a method of identifying tomato leaf infection recognition based on support vector machine. In image pre-processing phase, that used three techniques such as leaf image isolation and extraction, image resizing and background subtraction technique with some morphological operations. And from this paper, which is the plant disease detection using CNN by Sresha and Garima, it is correctly identified with a good conviction level. The communication remedy for the disease present is exhibited can be taken as a cure. And from the paper of robust deep learning based detector for real-time tomato plant disease and pest recognition sensors by Fietas and Yon, they have used the concept of image segmentation on potato leaf class of a plant village dataset, and then they applied multi-class support vector machine on the segmented image to classify the diseases in which they obtained 95%. And from the paper of a review of neural networks in plant disease detection using hyperspectral data information processing by Golani and Balasundaram, they have used an image segmentation approach for the identification and classification of fungal diseases on the grape leaves dataset. This work uses k-means clustering for extracting color, texture, and shape features from the images, and support vector machine is applied to the extracted features for the classification of the diseases. And the design and methodologies. Our project includes some 4 modules where the module 1 is the importing of the image from the dataset. We'll bring on our dataset using TensorFlow preprocessing image data create function. We'll generate size, rescale, range, zoom range, horizontal flip. Then we'll bring our photo dataset from folder through data create function. Here we set train, test, and validation. Also we set target size, batch size, and class mode from this function. We have to train by applying manual CNN. And to train the module by given image dataset. To insert our dataset by make use of unified and suitable create function, we build training steps per epochs and then total number of epochs. Validation data and validation steps using this data, we can train our dataset by applying VGG19. Applying the VGG-CNN. Here we will be applying VGG19 for training the model. Here we are giving more epochs, so we'll get the best accuracy result. Finally, we will compare with the loss and we'll identify how accurate is this when compared to other methods such as ResNet, LeanNet, GoogleNet, etc. So the plant disease identification. After performing training of the model, the the model will identify it will classify the types of images, whether it is an early blight or late blight, or it is an healthy leaf, based on the image given by the user. The training phase involves the feature extraction and classification using convolution neural networks. And standards and policies that we have used. The scope of the project it is to demonstrate the recent evolving technologies and mature enough to provide cost-effective and end-to-end precision farming services and showing farmers what technology can do to help their business and how deep learning can make them challenge the frequent loss in cultivation. We had used the VG19 architecture, and this project can be impoverished for future references by involving other aspects like disease prediction and furthermore which focus on study of prevention of loss for farmers. The architecture diagram. Here we have taken the dataset and the dataset is undergone data cleaning, and after data cleaning it will be undergoing pre-processing. From the pre-processing stage, the features are extracted such as color, texture, shape, and size, and from then the dataset will be undergoing model. It will be build model building and takes place, and from the model building and the disease is classified whether it is a VGG, it is a early blight or a late blight or a healthy leaf. And the data flow diagram, we had collected the data from the Kaggle. From the Kaggle, we had stored the data set, and that data set is uh, pre-processed using lambda function, where it will be scaled, resized, and filtered using lambda function, and then training the dataset using VGG19 model. After training is performed, the dataset will be tested, and later testing the features are extracted. After the features are extracted, finally the disease is classified whether as early blight or late blight. In the ER diagram, it is nothing but entity relation diagram, which tells the relation between the entities, where the entities here, two of the entities are potato leaf and CNN model and image, and the relation between them is the potato leaf is given to the CNN model, attributes of the CNN model, that is which consists of which are present in CNN model, that is convolution layer, fully connected layer, and pooling layer. The CNN model VCC19 model consists of 8 convolution layers, 6 fully connected layers, 6 pooling layers, and 3 fully connected layers. That CNN model, it will classify the image given by the user, whether it is an early blight or a late blight. The sequence diagram. First, the data set which is present in the hard disk, it will be stored, it will be loaded through TensorFlow. From the TensorFlow, it will be undergoing pre-processing stage, and the pre-processing stage, after the pre-processing stage, the data set which is present will be undergoing model building using VGG19 model. So it will perform training. After the data set is trained, it is compared, the image which is given by the user, it is compared with the data set, and it is classified whether it is an early blight or late blight, and finally it is given back to the user after identifying the result. The collaboration diagram, it also follows the same steps. First, the user gives the input, and it is the input is the potato leaf. That potato leaf will be compared with the data set which is already present with us, which had already undergone all the steps of pre-processing, feature extraction, and model building. And finally, it is compared with the disease classified leaves and gives the output as what's the actual output and the predicted output. If both are same, then it's giving the accurate result. So the types of testing are performed is unit testing, integration testing, functional testing, black box testing, and white box testing. Unit testing means that the image is taken as input and we get output in the form of images. We tested this system in different cases with different images. Integration testing, assessment test or integration test. It is a software test that perform different combinations that are combined and tested as a group. The purpose of this test level is to extract communication from the interaction between the integrated units. Test characters and test frequencies are used to assist in integration testing. Functional testing or final test. It is a type of software test in which a program is installed against a specific specification. Tests are enabled by means of installation and tests of the test result. White box testing or assessment board testing. It is a software testing system that tests structures or application performance as opposed to its functionality. Black box testing, it is a method of software testing that examines the functionality of an application without peering into its internal structures or working. This method of test can be applied virtually to every level of software testing, unit integration, system, and acceptance. And the input given is that different kinds of leaves which is taken from the Kaggle, that is the leaves affected with early blight and the leaves affected with late blight and some of the healthy leaves. The output is that it will predict the if both the actual leaf actual image and the predicted image if both are same and with giving an most accuracy, most possible accuracy, then it is the output. Here our output will be generating the maximum accuracy of 98%. 9. So it is preferable to use VGG19 in case of image classification. And the conclusion is that it has performed a uh, it has given us the great result with an accuracy of 98%. So it is preferable to use this VGG19, especially for image classification applications. So because we had used all the VGG19 model and also the data augmentation technique for increasing the amount of data set, and the future enhancements is that so there is a possibility of developing an application, mobile application, so that the user can directly take the photo of the image of the potato leaf which is affected with some kind of disease, and if he scans the image, then application will be automatically giving that result of what kind of disease it is affected with. Thus he can identify the disease at the early stage and he can take all the necessary steps so that uh, there won't be any reduction in the potato production. And the web references we are taken from the ResearchGate and IEEE Explorer, and for the YouTube links we are taken for VGG19 architecture and TensorFlow. And these are all the references, and this is the poster presentation where we can see that epochs and the epochs which are running, number of epochs here. We can see there are number 10. There are some 15 epochs. The total of the number of epochs is dependent on us. So to get the maximum accuracy, we can give the maximum number of epochs. Epochs means that it's the number of times our system has to train, our model has to train, and the graph which shows that training and validation accuracy and training and validation loss at the starting stage. At the first epoch, there is huge loss and the accuracy will be very low. When they as the increase in the epochs, the accuracy also will be increased and the loss will be reduced. Hence, we can conclude that the number of epochs is increased, the accuracy is increased, and the loss will be decreased. Especially in VGG19, this is giving the most accurate result. The accuracy will be very higher in this VGG19 model. And now we'll go to the implementation part. We had implemented this in Anaconda prompt environment. Inside the Anaconda prompt environment, we had gone for Jupyter Notebook. Jupyter Notebook, it is a user-friendly environment where we can execute the code clockwise, and it is easy to identify the errors. We can load the dataset and we can change the, even though without loading the dataset, without reloading the data, without reloading the web, without reloading the page, we can directly access the data, and uh, we can load the dataset, and it involves some directories. It involves the path should be given exactly for efficient execution of the project. And here it is stored in this, and this is our dataset, early blight, late blight, and healthy. So if we see here, we can see some large number of huge amount of data set of potato blight, lately blight, where we had used some 1,000 images, and for late blight we had used 1,000 images, and for healthy leaf we had taken some 125 images. So here we will be having all the directories, that is TensorFlow, Matplotlib, and NumPy. TensorFlow is it is a package which is taken for dataset, and Matplotlib it is for giving the output in the form of graphs, and NumPy, the here we have taken all the images as dataset, and the model cannot understand the images. So in order to be understandable to the model, we convert those images in the form of numbers, and that numbers in the matrix format. So for dealing with those numbers, we'll import the NumPy package, and this image size, we are fixing the image size as 256, which is nothing but we are fixing the size of all the images as 256, and batch size, here the batch size is 32, because this is taken uh, to tackle the storage problem, because as the huge amount of data set is required, it is not possible for the hard disk to store. So to avoid that problem, the data set is divided equally into batches. So here a number of batches is 32, and three channels we are using is three, that is red, green, blue, RGB. Epochs it is 5. It's based on the uh, our it is based on the how much accuracy we need. The epochs can be changed to our wish, and the data set, here we are using some 2,152 data images, where 1,000 images is of early blight and 1,000 images is of late blight, and 152 images is of healthy leaf, which are belonging to three classes, and these are the class names: early blight, late blight, and healthy. So length of the data set is 68, and this is our input. Images is nothing but the images of late blight, early blight, and healthy leaf. So the length of our dataset is 68. So total of out of the 2152 images, 80% is used for training the model and 20% is used for validation. Out of 20%, 10% is used for testing. So the length of the dataset is 54.0, and here all the length of the dataset, test dataset, validation dataset, and all the length is shown. And here it will be resized and rescaled for like resized because for giving the same size of all the images, as the images, different images will be of different sizes. In order to bring them in same size, we'll be using this resize and rescale function. Data augmentation, it is a technique used because to increase the number of dataset. As in the deep learning project, we need huge amount of dataset. So uh, this data augmentation technique will multiple the images. So this the data augmentation is used for that purpose. And here we are given three classes, and the model building, here the model building takes place where consisting of 8 convolution layers and 6 pooling layers and 3 fully connected layers. So here the model building will be takes place. After the model building, activation function used is relu and the softmax at the final layer, the last fully connected layer. The activation function used is relu and softmax, which is consisting of some huge number of trainable parameters. So here we used the number of parameters used is 1,83,747 parameters, and this epoch will define the accuracy of the model, accuracy of the project. So at the epoch, at the first epoch, the accuracy is a minimum of 48% with a loss of huge loss of 91%. As the number of epochs are increasing, the accuracy reached 90% and the loss reached to 25%. So this with the increase in the number of epochs, the accuracy will be increased and the loss will be reduced. So this graph is the output of our project, which is training and validation accuracy, training and validation loss. Both the graphs at the first epoch, there is a low accuracy. With the increase in the accuracy, there is a huge increase, there is a huge development in the accuracy. And here it is just only for 5 epochs. If we give the maximum number of epochs, it will train more number of times, and for each time it is training, it will extract a more number of features, thus increasing the accuracy. If the accuracy increase, there will be decrease in the loss. So at the first epoch, the loss is very high. So if the increase in the number of epochs, the loss is slowly reduced, and finally it reaches to a minimum stage when it given maximum number of epochs. Thus this is the output. We will conclude that using VGG19 model, we can get the maximum accuracy of some 98.9%, which is approximately equal to 99%, which is best among all the modern technologies such as LeanNet, ResNet, and etc. So with this, I conclude my presentation. Thank you.